Welcome to Maths and Science Intervention Club. My name is Mr. Nkuna, and today we're going to be doing a complicated arithmetic sequence whereby we are not given the sequence, but rather we are given a sequence in terms of p. So let us say we have an arithmetic sequence here. We have the first term as p, the second term as 2p plus 2, the third term is 5p plus 3. So the weight 2p plus 2, it means 2 multiplied by the value of p plus 2. So let us say this is our arithmetic sequence. So the first question says, determine the value of p. So now the moment when they say it's an arithmetic sequence, something has to also ring into our mind. What do they mean when this sequence is an arithmetic sequence? So now if it is an arithmetic sequence, it means the first difference, it is common between my terms. So now it means if I say T2 minus T1, that will be the same as me saying T3 minus T2, because in an arithmetic sequence, the difference, it is the same throughout. The difference between two consecutive terms, it is the same throughout. So if I say T2 minus T1, that will be the same as me saying T3 minus T2. So what is T2 minus T1? T2 minus T1. Therefore, it's term number 2 minus term number 1. Term number 2, it is written as 2p plus 2 minus, what is the first term? The first term, it is p. But what I know is that in an arithmetic sequence, the difference, it is the same throughout. This will be the same as me saying T3 minus T2, right? So I'm going to say, what is the third term? The third term, it is 5p plus 3 minus, what is the second term? It is going to be 2p plus 2. So now if I have something like this is like, it takes us back to algebra, whereby we are now solving for p. So I'll have 2p plus 2 minus p, which is equal to 5p plus 3. This negative is going to be distributed to everything that is inside the bracket. So it's going to be negative 1, because I have a coefficient of 1 here. Negative 1 multiplied by positive 2p, I'll have negative 2p. And here this negative is going to be distributed also to 2. So I'll have negative 2. So because it's going to be negative multiplied by positive 2, which gives us negative 2. So now here it's all about now grouping my like terms. So now with like terms are the terms that have the same base, which is raised to the same exponent. So what do I mean? If I have p plus p squared, these two are unlike terms, although their bases are the same, but then their exponents are not the same. Therefore, these two are unlike terms. But then if I have p to the power of 2 plus x to the power of 2, these two also are still unlike terms, although they have the same exponent, but then their bases are not the same. So now with a like term, it means they should have the same base raised to the same exponent. Therefore, these are like terms. They have the same base, which is p, raised to the same exponent, which is an exponent of 2. So now we have to see these two are unlike terms, and these are alike terms. So now coming here, can you see here, I have p, which is a base, which is, I can say it's a variable, which is p raised to an exponent of 1. I also have a p here, which is a variable raised to an exponent of 1. Therefore, these two are like terms. So I'll say 2p, I'm going to group my like terms. So I'll have 2p minus p plus 2, which is equal to this 5p and this negative 2p are like terms because they have the same base, which is p raised to the same exponent, which is an exponent of 1. So I'll have 5p minus 2p, then I'll have plus 3 minus 2. So here I'm going to have, what is 2p minus p? I'm left with p plus 2. Then on the right hand side, what is 5p minus 2, I'm going to have 3p. Then what is 3 minus 2? I'm left with 1, positive 1, plus 1. So now when it's like this, I also have to group my like terms. I can choose to group the terms that are with p's on the left-hand side. Then I group the terms that are having the constants on the right-hand side. So it means I can choose to say this p, I am going to have p's on the left-hand side or p's on the right-hand side. But then how do I group my like terms? I have a p here, I have a 3p there. Therefore, I have to group them. I have a 2 here, I have a 1 there. It means I also have to group my constants together and my variables together. So what am I going to do? I am going to say this p here, it is positive, right? Therefore, it means I can introduce a what? A negative p here. But then when I introduce a negative p here, it means also there I have to introduce a negative p. Because whatever that I do on the left-hand side, I should also do it on the right-hand side. It means even here I'm going to introduce a what? A negative p. But then this negative p and this p, they are going to sum up to what? Sum up to a 0. Right. Look here. Now I am only left with positive 2. But then I still have a 1 there. It means this one here, it is positive. It means I have to introduce a negative 1 there. But then when I introduce a negative 1, it means I also have to introduce a negative 1 here. Therefore, I'll have minus 1. Right. So here I have a 0. So I will have negative 1 plus 2, which is equal to this 1 and that negative 1. They are also going to sum up to a 0. Then I will have 3p minus p. Therefore, what is negative 1 plus 2? I'm left with what? I'm left with 1, which is equal to 3p minus p. I have 2p. I have 2p. So now I'm looking for the value of p. It means I have to do something with this 2. It means I can divide both sides by what? Divide by 2. Divide by 2, which makes the value of p to become p is equals to 1 over 2. Now I know the value of p. Can I be able to find the sequence? It means wherever I see p, I can substitute the value of p. So the value of p, it is 1 over 2. It means the first term, it is going to be 1 over 2. So now when I'm looking for the second term, it means wherever I see p, I can substitute the value of p, the one that I've calculated, as 1 over 2. It means here I'm going to have 2 multiplied by 1 over 2 plus 2. Therefore, on the third term, wherever I see p, I am going to substitute 1 over 2. So I'll have 5 multiplied by 1 over 2 plus 3. This is my what? This is my sequence. But then I can still simplify on my sequence. Therefore, the first term is strictly, it is also going to be, the first term, it is also going to be 1 over 2. What is the second term going to be? 2 multiplied by 1 over 2, it is going to be 1. Then I'll have 1 plus 2, I will now have 3. Then what is the third term? I'll have 2. I'll have 5 multiplied by 1 over 2, which is going to be 2,5. 2,5 plus 3, I am going to have 5,5. Or I can write it as a fraction, but then even if you write it as decimals, it is still the same. I have 0,5, I have 3, I have 5,5. Now let me confirm and find my difference. So my difference between my two consecutive terms. So for me to find the difference between two consecutive terms, I say T2, which is 3, minus 0,5. I will have 2,5 as my difference. Therefore, for me to find also the difference, I'll say 5,5 minus 3, T3 minus T2, I'll have 2,5. Therefore, this also confirms that whatever that we were dealing with here, it is an arithmetic sequence. Because I know that in an arithmetic sequence, the first difference, it is common or it is constant. So the first number that you're going to find as the difference here, it is going to be the same throughout. That is why we say T2 minus T1, it is equals to T3 minus T2. Because the difference between two consecutive terms, it is always going to be the same in an arithmetic sequence. Thank you so much. I hope you've enjoyed this educational channel. whereby we were looking for the value of P when we are given a sequence whereby we don't have the exact numbers, but then we are given a sequence in terms of P. So the first thing that we do, we have to know what is an arithmetic sequence and the properties of an arithmetic sequence. This is what you have to know the moment they say it's an arithmetic sequence. And after calculating the value of P, it means you can now substitute back the value of P to go back and find the exact sequence that it was before it was represented by P. Then the first thing that you can do, you can see that the first difference between my arithmetic terms to consecutive terms, it is the same throughout.